Let us start CBSE class 10th mathematics exercise 6.1 chapter 6. You see, the first question is fill in the blanks using the correct word given in bracket. You see, all circles are, so we have to choose correct answer from these two options. There is congruent or oblique similar. So I have filled here the similar. All squares are similar. Here I have filled similar from these two options. All equilateral triangles are similar. You see, the choice is given, that is isosceles oblique equilateral. So I have mentioned here all equilateral triangles are similar. Now the fourth is two polygons of the same number of the sides are similar if first their corresponding angles are equal and B their corresponding sides are proportional. So we have to place the appropriate, this equal and proportional at appropriate place. So that is why I have placed here that their corresponding angles are equal and their corresponding sides are proportional. Now come to the question number 2. Give two different examples of pair of similar figures. You see, we have to give the two examples like that. First one I have given A, there is two similar circular protectors. These are similar. Now B, that is two different sizes of the shadow of a particular tree. Means that if you take that shadow of a tree, they are similar of a particular tree. Non-similar figures, we have to give the two. So you see the scalene and isosceles triangles. These two triangles are non-similar figures. Now come to the B part, that is B, that is one trapezium and one parallelogram. They are also non-similar figures. Now come to the question number 3. Here, question number 3, state whether the following quadrilaterals are similar or not. You see here, rhombus is given, that is PQRS is a rhombus. Here ABCD is a square. Means all sides are equal and all triangles are equal to 90 degree. Here the sides are equal, but the angles of only opposite angles will be equal, but all angles will be not equal. So these figures are not similar as the angles are different. Now come to the exercise 6.2. You see question number 1. You see the figure. There is, here we have to find EC. In this case, we have to find EC. So this line DE is parallel to the side BC. Therefore, these sides AB and AC will be intersected by DE in proportion. So that is why I have written here AD upon DB. AD upon DB will be equal to AE upon EC. So AD is 1.5 and DB is 3 centimeter. AE, that is 1 centimeter, and EC we have to find out. So cross multiply it, you will get EC is equal to 1 into 3 divided by 1.5. You will get 10 by 5, that will be equal to 2 centimeter. This will be the answer. Now in this case also, DE is parallel to BC. Find AD. We have to find AD here. So AD upon DB is equal to AE upon EC. That is basic proportionality theorem. So AD is unknown, but BD is 7.2, AE that is 1.8, and EC is that is 5.4. So AD will be equal to 1.8 into 7.2 divided by 5.4. Solve it, you will get 2.4. This will be the answer of question number 1. Second part. Now proceed to the question number 2 of exercise 6.2. You see, state whether EF parallel to QR. We have to justify whether EF is parallel to QR. Here you see the measure. First part is PE, that is 3.9, EQ is 3 centimeter, PF is 3.6 centimeter, and FR is 2.4 centimeter. So by Thales theorem or basic proportionality theorem, just suppose that this line is parallel. So let us assume it that the Thales theorem will be applicable or basic proportionality theorem will be applicable. Now put 3.9 upon 3, 3.6 upon 2.4, here you will get 1.3 is not equal to 3 by 2. Therefore, EF is not parallel to QR. Answer is no. Now the second part, here the P is given 4 centimeter, Q is given 4.5 centimeter, PF is 8 centimeter, and RF is 9 centimeter. Now substitute these values. P upon EQ is equal to PF upon FR. This gives you 4 upon 4.5 is equal to 8 upon 9. Cross multiply it, you will get 3.6 is equal to 3.6. Therefore, EF is parallel to QR. Here it is justified because these sides are proportional. So the answer is S. Now the third part. Here you see PQ. PQ is 1.28, PR is 2.56, PE is equal to 0.18 centimeter and PF is 0.36 centimeter. So EQ will be equal to PQ minus PE, that is 1.28 centimeter minus 0.18, that will be equal to 1.1 centimeter. Now FR is equal to PR minus PF, that is 2.56 minus 0.36, that will be equal to 2.20 centimeters. According to the basic proportionality theorem, BPT, basic proportionality theorem, that is PE upon EQ is equal to PF upon RF, that should be equal to 0.18 upon 1.1 should be equal to 0.36 divided by 2.2 and it should be equal to 1. Therefore, the basic proportionality theorem BPT is applicable here. Hence, EF is parallel to QR. Now proceed to the question number 3. Question number 3 states that LM is parallel to CB and LN is parallel to CD. Prove that AM by AB is equal to AN by AD. Here you see, LM is parallel to CB and LN is parallel to CD. Prove that AM by AB is equal to AN by AD. Now in triangle ABC, LM is parallel to CB. Therefore, AM by BM is equal to AL upon LC. That is basic proportionality theorem. The equation will be number 1. Now in the second triangle ADC, LN is parallel to CD. Therefore, AN by ND is equal to AL upon LC. That will be the second equation. From 1 and 2, we have AM by BM. AM by BM is equal to AN by ND. You see, just compare these two equations, you will find, you see, the AL upon LC, that is right hand side, RHS, both are same. Therefore, our left hand side should also be equal. So, AM by BM is equal to AN by ND. Now, QED. QED means quad erat demonstrandum, which was to be proved. This is the short form QED, and its full form is quad erat demonstrandum, which was to be proved. Now proceed to the question number 4. Now proceed, question number 4 is here, you see, DE. DE is parallel to AC. DE is parallel to AC. Prove that, so side by side, DF is parallel to AE. You see, by arrow mark I have represented it. D is parallel to AC and DF is parallel to AE. Now, prove that, we have to prove it that BF is equal to EF, BF upon EF is equal to BE upon EC. In triangle ABC, where DE is parallel to AC, it means that BE upon EC is equal to BD upon DA. That is basic proportionality theorem or Thales theorem. In triangle ABE, I am talking about ABE, DF is parallel to AE. Therefore, BF upon EF is equal to BD upon DA. That is basic proportionality theorem. This will be our second equation. From 1 and 2, we have BF upon EF, FE is equal to BE upon EC. And this was that to be proved. Now, hence, I have written here QED, quad erat demonstrandum, which was to be done. Now, question number 5. In triangle POQ, DE is parallel to OQ. DE is parallel to OQ. So in triangle POQ, so PE upon EQ, PE upon you see, PE upon EQ is equal to PD upon DO. PD upon DO. You see, this side, PE upon EQ should be equal to PD upon DOROD. Now in triangle POR. So again, you see, with the double arrow mark, I have shown the parallel line, that is DF is parallel to OR. So DF is parallel to OR by basic proportionality theorem. PF by FR. PF upon FR is equal to PD upon DO. PD upon DO. This is the second equation. From first and second, we have PE upon EQ is equal to PF upon FR. By converse of the basic proportionality theorem, it is proved that EF is parallel to QR. EF is parallel to QR. This is the base. Here the QEF is here. Now question number 6. In triangle OPQ, AB is parallel to PQ. You see, AB is parallel to PQ. Single arrow mark I have represented it here. So, OA upon AP, OA upon AP will be equal to OB upon BQ. This is the first equation. In triangle OPR, AC is parallel to PR. AC is parallel to PR. By basic proportionality theorem BPT, therefore OA upon AP is equal to OC upon CR. OC upon CR. This will be the second equation. So from first and second we have OB upon BQ is equal to OC upon CR. OC upon CR. The converse of basic proportionality theorem. Hence it justifies that BC is parallel to QR, and this was to be proved. QED.